So step one, whenever you're doing one of these related rates problems, is to try to figure out if it actually is related to rates. Okay, this one is kind of obvious because I went in order. So you should know this one's related rates. But if you see a bunch of rates all around this thing, that's usually a sign that you're going to need related rates. So it says like the radius of the sphere is decreasing at that rate right there. And then it says at the instance when the radius is 3 centimeters, what is the rate of change? So it's asking for another rate of change. They give you a rate of change. Somehow these rates are related to each other, and we're going to use that basically to solve. Write down the givens first. So it says, so we're basically just translating from English to math right now. So it says the radius of a sphere is decreasing at a rate of 2 centimeters per second. So I'm going to write dr over dt is equal to -2 centimeters per second. I'm not going to worry about the units for this because all the units are the same. It's all centimeters, it's all seconds. We can just throw that in at the end. We're going to abstract away that detail for right now. Okay, so that first sentence right here, I just translated that into math. So this part right here is good to go right there. Okay. Now it's good to translate this because we're going to eventually use, derivative notation. If we have everything in the calculus notation right away, it just makes it easier for later on. The next thing it says, at the instance when the radius is 3 centimeters. I'm going to write that down. We're going radius is equal to 3 centimeters. If you notice, I wrote r instead of dr over dt. This is the rate of the radius. This is just the radius period. One's the rate. One's just the regular value. And then it says, what is the rate of change? So at r equals 3, what is the rate of change of the surface area? So I'm going to write ds over dt is equal to question mark. Okay. So this whole second line here, r equals 3, ds over dt, is all based on that second sentence right there. And then it tells you the surface area S of a sphere is S equals 4 pi r squared, essentially. Okay, so that's writing on the givens. I also said a good rule of thumb too is to draw a picture, just so you understand what's going on here. So here's my best picture of a sphere, something like that. That's terrible, obviously. There's some instance when the radius of this sphere is equal to 3. Okay, and at that instance in time, if the radius is shrinking by -2 centimeters each second, what is that surface area? How is that surface area changing? Essentially, that's what we're doing. You don't really need a picture for that one. Didn't really need to draw that. Okay, the next step is to create a related equation. Okay, so the related equation is actually given here. It relates r with s. Okay, it's not a rate yet, but we have an r here, an r here, and an s here. So how I want you to think of that is there's two variables, essentially, the r and the s. How are they related? They're related with that equation that I just wrote right there. AP does tend to give the equations for these a lot of times, even if it's the area of a circle. Well, I shouldn't say area of a circle, but a lot of times when it's, people might forget the equations, they tend to give those to you. The next step from here, from this red step, would be to find the related rates equation, create the related rates equation. So what we're going to do here is we're going to do d over dt of both sides. So we're going to do d over dt of s, and we're going to do d over dt of 4 pi r squared. Okay. Step 2, after you drew the picture and wrote the givens, that was step 1. Step 2 is this red step right here. That's the related equation. Step orange is the next step where you make a related rates equation. Okay, the s and the t do not match, so we're going to do the derivative of s, which is just going to be 1 times ds over dt, if you remember our implicit differentiation rule. Okay, 4 pi is a constant, so we're going to kind of ignore that. I'm just going to write it out here. So it's going to be 4 pi times. Now we have to do the derivative of this r squared. The r does not match the t, so you have to do the derivative like normal, 2r, and then multiply it by dr over dt. So now that yellow step is our related rates equation. There is only one more step, and that's to plug in everything you know and solve for what you were looking for. And this is why it's helpful to write everything that's given here in the standard notation that you're going to see here. So dr over dt, we know that this thing right here is just equal to -2. Okay, 4 pi is always going to be equal to 4 pi. 2 times r, well, r is 3. Okay, so we know everything on this side of the equation. We're looking for ds over dt. So this will help us solve it out. Let's see here. We end up with a negative. Sometimes I look for it right away and just notice, oh, they're all negative, so that's not really going to separate the pack there. But we got what, 8 times 6 is -48. So your answer is -48 pi. centimeters squared per second. An easy way to tell that it's centimeters squared is its surface area over time. Surface area is centimeters squared divided by time is seconds.